Oh man, it's gonna get hot today. Hello and welcome to another Solana tutorial. I have an exciting topic for you today. We're gonna talk about vanity addresses. Cause if you know me, then you know that I love vanity addresses for Solana. Because in every video I'm grinding myself a new vanity address. Or several. But we're always limited to like 4 characters. 5 at most if we're lucky, and use the right starting letters. I did make videos about vanity addresses before, like we talked about this. But today, I want to have a look at a tool that promises that we can grind vanity addresses more efficiently and therefore faster and therefore have longer vanity addresses. So my goal is to get that tool to work and compare it to the regular solana-keygen grind, such that you know whether or not it's worth it to use that tool. But maybe we should start with, for the people who are new, what is a vanity address? Basically, every account on Solana has an address, right? So also your wallet will have an address, a program will have an address, also called the program ID. Your token mint will have an address, because everything on Solana is an account and every account has an address. That's how you find it. Right. And so usually those are random base 58 strings, but if you don't want them to be random, you can find specific addresses that start or end with, or even have in the middle, some interesting sequence of characters. Then we're talking about a vanity address, because we decided what it should say. You probably know this from like token something something, or the tokens that end with bump. Those are all vanity addresses. And from a purely technical perspective, vanity addresses are pretty useless. They don't really buy you anything. It's not more efficient. You don't need vanity addresses to work with Solana. You can go your whole life without using them. But I, and probably also a few other people, still love them because they give you street cred, basically. So for me, if I see a very long vanity address and I'm like, wow, they grinded a really nice address here, they are committed to this. And also, if somebody uses a vanity address, I'm like, they know what they are doing. They're not just random script kiddies who just do something like Circle. I'm still sad that Circle doesn't use vanity address for their USDC. That would make life so much easier. Or when they introduced Euro, I was like pretty sad that it didn't start with Euro. Anyhow, so in my eyes, you lose kind of, what is it exactly? Is it seriousness? Are people not using vanity addresses less serious? No, it's more of a, I like it if people pay attention to detail. And having a vanity addresses for your program or your mint or even your wallet address just shows me that you care. So whenever I deploy a program, even if it's just for testing purposes, I love to have vanity addresses. So I need vanity addresses. So I need a tool to efficiently grind vanity addresses, potentially even using my GPU. Never done that. We're gonna try if we can get that to work today. So let's get started grinding ourselves some vanity addresses. Let's start with a solana-keygen. Because how we usually grind vanity addresses is we say solana-keygen grind and then starts with or starts and ends with or whatever we want. And then we type the starting letters that we want. It's more efficient if you start with A to H, capital, and we talked in a previous video about why that is. And then you say how many you want. So now let's just do a baseline for comparison. Obviously it can't be just one because that's fairly random. Let's grind 10 addresses that start with Andy and see how long that takes roughly. My green screen is not particularly clean right now. Is that better? No, now I'm transparent. I'm just a ghost. It is as it is. Okay, where were we? And just for reference, I'm also gonna show you what we're using because this will be grinding purely on CPU. So if I start this, then my CPU usage will spike. We burn, and it's actually relatively fast to find Andy, like 4 letters. That's not bad. I think they also did improvements on the solana-keygen, but it does still take a while. If we want to get 10 key pairs, we need a minute or so. It's my current estimate. And we found 8, and we found 9, and we found 10. 52 seconds. That's roughly a minute. And obviously you see it here. Here we found a lot quickly after each other. Then for a while we didn't find anything. So obviously the minute is not a clear value. If we wanted more exact, then we need to have higher numbers and grind than, I don't know, 100. But this is good. We're in the range of a minute. That's roughly true. So now I want to compare this to a tool called Vanity by Cavemanloverboy. This guy, by the way, is one of the sickest Solana devs that I know. I've met him at Breakpoint once. Man, that guy is just wow. Okay, all the stuff he builds is usually quite nice. So also this thing, I think I even had a look at it at one point in a very early version, because that was the tool that worked with a create account with seed to bypass the ED25519 and just have SHA-256 hashing to compute vanity addresses. But it does also support the grind key pair, so a regular key pair like what we did right now with the solana-keygen CLI. So that's what we're first gonna compare it with, and then maybe we look at the grind to get even faster. But let's just compare how this grind key pair compares versus this keychain grind. So we gotta install this tool using cargo install vanity. And there we go. It's building the binary. I'm a ghost. Okay, so now we should have vanity, cool, where we can grind key pair, grind Doppler. And what we want to do is grind key pair. Vanity, grind key pair. What does that take? Oh, it just grinds me a key pair. Okay, hold on, that's not what I want. Tell me what I need. So we can specify a prefix, we can specify a suffix, which honestly, this is much nicer than how the solana-keygen does it, because that will have a starts with, it will have an ends with, and it will have a starts and ends with. And then you need the prefix, suffix, count, which is just weird. If you have it with prefix, and you can add the prefix, and suffix, and you can add the suffix, then you have both, and you don't need to have the third case where you use both. So yeah, it also has the ignore case, so case insensitive is what it's called here, and how many we provide with a count. And then we can also tell how many CPU threads. Default is 0, which probably takes all the available ones or whatever. I don't know. We'll try. So let's do the same thing with prefix Andy and count 10. That's the equivalent of what we did earlier. Let me pull up this thing again. And now let's go grind and see what my CPU does. It spikes to 100%. Great, so nothing super interesting here. And we find Andy matching pub key. It gives me the seed. We're at 25 seconds. Wow, I'm really transparent. But it's good. Then you see what's behind me and I'm not in the way. I'm such a ghost today. It's okay. It's fun. And doesn't seem like we actually win anything with that. We are also at 51 seconds now and 57 even. So same ballpark. 1 minute for 10 Andy addresses. So yeah, we didn't really win much with this, at least not by itself. Also, this thing does not actually store the key pairs anywhere. If I would want to save them, then I would need to copy that out of here. Whereas the keygen, if it finds something, then it saves it to a file. That's just a difference that you gotta know. But yeah, those are Solana compatible actual key pairs now. But as you saw, if we're doing this, we're just grinding on the CPU, which is not the most efficient, especially if we do have GPUs available to us. I have this nice, well, is it nice? I don't know. I have it. I have another dedicated NVIDIA GPU on my computer. This time it only took 38 seconds, so slightly faster, but still in the same ballpark. I would actually need to run this a few more times to actually get a proper feel if it's actually now faster even a bit or not. So let's run that a third time before we then move to GPU. It's funny that it always says estimated grind time 4 seconds. There we go. Now we're at 40 seconds. So again, it's slightly lower than a minute. And just to compare one more time with the solana-keygen, which same or similar ballpark, this time also just 40 something seconds. So with those tests, I cannot say that any of them is more efficient than the other one. It's just they're roughly the same here. The interesting part would now be, can I run Vanity using GPUs? Because that should basically double my key pairs per second. Not a huge improvement, but hey, double is double. And then we'll have to look at the seeds, because that's where the real efficiency lies. But first, let's try and get it to GPU. It requires the toolkit NVCC, right? So for now, we did not install with featured GPU. That's why we don't get any, we just get the CPU stuff here. So if I install with features GPU, it will probably tell me, you don't have CUDA, right? Or maybe it does. Or if I try to run it, it will fail. We'll see. Yeah, that's already not looking good. Error, caused by. There we go. Compiler family detection failed due to error NVCC. We don't have that. So how do you install that? CUDA installation guide for Linux is that bright. Wow, I'm a real ghost here. Yeah, my green screen. Let's vibe research this. What could possibly go wrong if I just execute that, right? Developer download nvidia.com. Let's do this. Bidoo. Security Ubuntu. 700. What? 6 gigabytes of additional disk space will be used? What? Holy smokes, what are we doing? But I like that. Developer repos WSL Ubuntu. It has WSL Ubuntu stuff. That's a lot. 6 gigabyte of drivers? What the hell? I also like those numbers. That's expected. Meta package installs way more than NVCC. It pulls the entire CUDA. So you can also get the minimal build. Yeah, but whatever, let's get everything. I might delete this later. Unpacking all of that. All of that. Whoa, yeah, okay, cool. 133. Still liking this. Okay, without having the Windows drivers installed yet, I export the paths and load them again. And then I should have NVCC. Yeah, there we go. I have that now. And with that, I should hopefully be able to install this with GPU. Hopefully. Yeah, it's building. No! Damn! What? Control driver, not the CUDA. Okay, I exported those two things and now I try again. It's just because we have it on WSL and it expects the drivers somewhere where it can't find them. But vibe coding, man. Vibe installing. Why not? What? Nice! Look at this! It built! Doesn't mean that it's gonna actually work, but it built, that's the first part. So, Vanity grind key pair now has number of GPUs. Ha ha ha! And it defaults to 1. Ha ha ha! Okay, so let's do the same thing that we did before and see if A, it still works, and B, it uses my GPU, and see if it's any faster. Let's go. It still works. It is using my CPU still. Oh, also my GPU. Look! It's burning GPU and CPU time. Amazing. Well, that's great. Being efficient. Just use both. And we'll see how long it actually needs. Doesn't seem to be gaining much though with burning GPU time, because yeah, still 35 seconds, which is on the lower end of what we had earlier, but I'm gonna let you do it again just to compare. One more time. Burning more CPU and GPU time. Telling you, this is my heating. Not like I need that in summer with 30 degrees, but anyway. I applied new cooling paste, so I can afford to do that now without my computer completely dying. If I would have done that 2 weeks ago without the new cooling paste, it would have been bad. Anyway, we see it's not really gaining much. I mean, it's trying, but maybe that GPU is also just not particularly good. I don't know. Cool. CPU is done. Look at that. But the GPU is still grinding. That's an interesting observation. So the remaining stuff is still done on GPU. And here maybe really it's just my GPU being weak, that it's taking even longer than just on CPU. Okay, great. We didn't win anything except that we can now use the GPU. Woohoo! Okay. Fine. Okay, let it cool off. This really makes sense if you have a proper GPU, like a strong one, then you probably gain efficiency with that. In my tests on my computer with just a regular laptop GPU, probably not worth it, but I wanted to see anyway. However, maybe if we're doing hashes, it does pay off. So let's test that as well. If we're not doing the grind key pair that needs to use the ED25519, that is slower because we have one per attempt. Let's use the one that just SHA hashes and finds a seed with grind. So first, let's do this in 2 steps. First, let's grind an actual key pair that I like, a proper one with NDS, just one, 20 CPUs, 1 GPU. Estimated time is 3 minutes to find a key pair starting with NDS like that. Yeah? Because that's certainly more difficult. The more letters you add, the more difficult. But I want one with NDS, give it to me. Find one. I've got all my GPU and CPU time. Find one. Expected 192 million attempts. That's a rather low probability of finding that. We do 500,000 attempts per second, and we're getting we're getting there. So I will be able to get one of these. And that's actually the better comparison. Like, that's a proper number that we can use. The attempts per second, we're roughly 500,000 attempts per second. And I'm curious if I actually say number of GPUs is 0, if we just grind on CPU. So now we're not letting this one grind, but just on CPU, like what we did before. If that number is any higher, not really, it's slightly lower. So adding the GPU did buy us a little bit, although that is still rising as well. Yeah, tiny bit maybe. Let's go back to the 2 minutes. Oh, or not, maybe not. Why is this getting more and more efficient in terms of attempts per second? And now at 1 minute, now we're even faster without the GPU. So in our case, adding the GPU did not make sense. Yeah, if we compare at the same time at the 2 minute mark, maybe it does some memory or efficiency cache stuff that it's getting more and more efficient the longer it runs. So yeah, at the 2 minute mark, we are faster than we were when we were also using the GPU. Okay, good to know. So using my GPU didn't give me anything. I still want an NDS key pair though. Gotta go one more time this much to reach the expected attempt. And that still doesn't guarantee that we actually find it in those attempts. It's just expected to find one in so many. But maybe we're unlucky and we need much more to get the first one. What's probabilities? Anyhow, let me kill this and use the solana-keygen to grind an address starting with NDS1. Because I want to compare the time, because it also tells me the attempts and it tells me the time. It just doesn't tell me the attempts per time like it did with the other tool. So I will need to calculate that myself. I have 10 million in 21 seconds. And then we get 20 in 45. So it's roughly 22 seconds, or 30 million in 69 seconds. So yeah, it's 23 seconds per 10 million. So let's calculate if that is faster compared to what we have here in attempts per second. Because we had 10 million per... Oh, it found one! 23 seconds, which is, yeah, also 434. Here it was actually in the 700s. So comparing those numbers, we could say that the Vanity grind is actually almost twice as fast as the solana-keygen grind. Of course, that also depends on the run and whatever, but roughly that's what we're comparing against. So here we now even found it in 48 seconds after that many attempts, because finally we got lucky. And we have an NDS key pair that I still don't like because there's another capital letter here and then it's not NDS, it's NDSMK. Should we grind again? How is it at 1,000,000 attempts per second now? That's crazy. Hey Cavemanloverboy, can I have a direct export of the key pair like the solana-keygen does, such that I never have to show it in the output? I mean, yes, most of the times that's the cleaner way to not leave traces and not put it on the disk, because you don't want that usually. And if it's in the output, it's safest. However, for me as a visual video maker person, it's a bit inconvenient, because as soon as I have that in the video, everybody has my key. So it's just, I want a feature where I can not show this. I mean, obviously I could also just not show people and say it's done, but that's just not as nice, you know? So I'd like a feature where I can say write to file. And I could, of course, implement that myself or write code it, but no, rather I'm telling you that's what I want. Anyway. Okay, so do we find another one? We are still at the 700 roughly attempts per second. Otherwise, I'll just stay with the other one. How hot are we? I don't even see that here. Wait, I can show you this, because that is another reason why performance might go down if we're thermo throttling, which we are not even doing, even though I'm running on like 100%. That's crazy. The thermal paste really paid off. Side note, if you have an older computer, change your thermal paste. It will make cooling much more efficient, and then you don't need to thermal throttle, which is good, even if you're burning on 99% CPU. That's great. I'm so happy I changed my thermal paste. Nice. I thought that I would see some throttling here, but I don't. We're still grinding. Okay, anyway, doesn't seem like we find another one, do we? So yeah, 5 letters? Difficult, especially if you're case sensitive. Okay, let's get one with, just so we also tried that once, with case insensitive. Let's go. That should be faster. Wait, what? The expected number went up? The expected number for case insensitive went up? How does that make sense? There's a bug. Okay, this one I report as a bug, because that can't be. However you calculate those expected values, clearly this is quicker if we allow more characters than if we have case sensitive, which you report with lower expected attempts. What? Well, yeah, so Caveman, this, look at the, or I mean, not like it's important, but there must be a bug somewhere. Last try, otherwise I take this, because this actually does look nice. I want to have this one. Andy Do. And then it almost says hotel here. That's what I read, hotel. Anyway, so I'm gonna use this one. So don't forget to actually save the key pair. Now I have it on disk and several times in my logs, and you know it too. So we're not actually gonna productively use it, but we are gonna double check that it can read that. Yes, good. It can read my hotel key, starting with Andy S. Why did I do that? Because I need a base key. In case you haven't watched that video where we grind the seed for the create account with seed, that's what we're gonna do now. We're gonna vanity grind. And that stuff will need the base, the owner, prefix, suffix as before, and the number of GPUs, CPUs as before. Okay, so we're gonna grind with the following base. That's my address. The owner, I want it to be a regular system program wallet, so I will set the owner to the system program, my favorite pub key. That's not actually a vanity address, that's a defined address. Also this, I wouldn't call it a vanity address, although in a way it is, but it's not a grinded vanity address, it's somebody decided that's the address. Yeah, anyway, that's a vanity address though, for token, and then they grinded for token, and it came out with token keg. That's why we call the token program token keg. So yeah, vanity addresses are important is my point. Because you know now the entire token program is known as token keg. Because that's just what came out when you vanity grinded it. Yeah, that legacy stuff stays around. So you know, better vanity address is better. I'm just saying. So where was I? Yeah, owner and then the prefix. Let's start with the same prefix of Andy and just see what we can do here and get again 10 just to see if we are any quicker. Number of GPUs are set to 0. Let's try this. I mean, okay, that's clearly faster, but also we are doing a different thing, so you can't compare that. That would be a very unfair comparison. I'm so transparent. It's so ridiculous. So with this, we should be able to get NDSs though. The expected attempts are the same, but the number of attempts per second should be dramatically higher than what we had before. It doesn't seem to be though. We're just at 40 million attempts per second. What did we have earlier? Oh no, earlier we had 400, now we have 40 million. Right. So it is significantly faster. Yeah, that makes more sense. Okay. And see, we are getting 10 of those addresses in roughly 40 seconds. So that's a significant increase in speed, even only using CPU. Let's try something that is very difficult to get. So just that we have those numbers and I just see those. Because we're here at roughly 50 million attempts per second. I just want to let it adjust and see what number this settles on. Because especially having a 1 is very special. Like this, it's very difficult to get a 1. Because there would be an actual 0 in the bytes. So 1 basically counts for 2 letters or 3. I don't even know, but it's more difficult to get that. So we're at 40 and decreasing. Yeah, a bit under 40. And just to show you, if I would do Andy 1, then it would be... It still says same expected attempts, which is also not correct. But this is also just an estimate, right? It's not doing it fully, the full exact probability. The probability is probably just based on the characters. Oh, maybe that's why. I think I found your bug. Because if you're calculating the probability based on characters and then you make this a lowercase character, then obviously the probability is even lower. But anyway, my point is that those are more difficult to find than NDS. Because here after a minute we found 1, 2, 3, 4, 5. And with NDS we already have 5 after 30 seconds. So this is easier to grind than this, was my point here. Why? Because a 1 represents a 0 byte. After a minute we have 10. There you go. It's roughly double. Okay, anyway, I'm getting sidetracked again. We are at roughly 40 million attempts per second with a CPU. That was CPU only. Now, let's see if here for the hashing, it actually helps me if I use a GPU, set that to 1, and see if we're any faster with that. Even though my GPU isn't the strongest one, let's compare that, because I'm curious. We're starting higher. We're starting with 50 versus 30 or 40. Let's check. It is using GPU and CPU. Yeah, you need the CPU as well for stuff. And after a while, it's getting down to the other ballpark with the 40. So I'm not sure if that actually helps me. Maybe a little bit. Maybe the GPU helps a little bit. Yeah, but only a little bit. It's only 10 million attempts per second additionally. But if we see that 20 CPUs actually produced 40 million and one GPU produced 10, that's not bad. So wait, let's pin it down. Let's use just one CPU. Let's CPUs. One CPU, so we're just using one core, that it doesn't overwhelm my computer. Then we're at roughly 4. Oh, that was a nice number. Did you see that? Million attempts per second. Does that scale with number of CPUs? Is that now 8? Yeah, roughly. Is that now 16? Yeah, roughly. So let's say 7 on 2. So 3.5 per CPU. So if I have 10 cores, then I should have 35 million roughly. Yep, there we go. Wow, that checks out. So that really scales per CPU. Great. But then I can't really tell it to use 0 CPUs. Or can I? What happens if I have 0 and 1? Does it then... Yeah, 0 means take all of them. That's not what I wanted. Okay, let's pin it down to just 1, and we know it's roughly 3.5 million attempts per second that we get from that. And GPUs, I just have one, but yeah, please use it, such that we can calculate how much we gain from the GPU, and it's not much. Oh, actually, wait. Yeah, after a while, this is starting to scale. Hold on. We started with 4 million, and now we're at 26. Hey, that's not bad. So that's just the GPU doing that. For this way of grinding, yeah, that's roughly where we stay at the 20, 25, 20, minus the 3.5 from the CPU is still roughly 20, something above 20. So my monkey brain math tells me that this one GPU is grinding as much as 6 of my CPUs would grind, or CPU cores, and that's where they're running. Yeah, cool. I like it. And then both together, if I let you use all of my 20 cores that we have available, then we get to 44. But that now really burns through my entire CPU. If I don't want to heat my flat so much, I could just tell you to use half of them. And we still get a decent amount. We just need to wait a bit for the GPU to properly kick in. There we go. Now a GPU kicked in and we're also at 30, 40, something like that, without having all the cores burning. Actually, I only have 14 cores. Why did it? Oh, logical processors, it has 20, but I only have 14 cores. So really, what you're saying is, even at 14, it should get to 100%, no? Almost. And also the seed for this is nice. Spike curry. And if you want to know how to get from this seed to the actual account on chain, you gotta watch my video on the create account with seeds. Or should I show you real quick to finish this off? First, let's answer the question how many letters I could actually realistically grind with this. 6 letters should actually be possible with this. We've got a bunch of the expectation is high, but we can also do 50 million per second. So this should be in the 3-minute range to actually get 6 letters. So actually, let's search for 6 then. S6. Too much garbage here. So try again. Whoa! I mean, that was lucky. Honestly, that was just lucky that it literally found it in 0.5 seconds, because the next one it will not find that quickly. But yeah, the point is it is possible. It is certainly possible that we find an address, maybe even 6 or 7. Love it. Yeah, I love this. Okay, so point proven. This is the address that we're going to take. NDS67. And now I need to prove to you that I can actually use this address. I mean, obviously I can use this address by literally transferring 1 sol there. Boom. And now I can say, hey, check this out. We used this address that we grinded. But that doesn't help anything yet, because everybody can send sol to any random address. The interesting part is when you get the sol off this grinded address with 6 or 7 letters of grinded address. I love this address. This is a great address. I love this one. So now we need to get it off of there. How would we do that? Well, we'll need a custom transfer script for that. Let's transfer with seeds. So what we're doing is we're going to send the transaction. We need to pay with some other wallet. We can't fee pay with this wallet, because the thing is we can't sign with this wallet. But the system program still allows us to do stuff with this wallet. Good point. Actually, we need stuff from the system program, namely the get transfer sol with seed instruction. Get transfer sol with seed instruction, which takes the amount that we want to transfer. Let's do half a sol, then the base account, and this is the one that actually needs to sign, so we will need a signer anyway. That's the Andy Jason in my directory here. So here my Andy Jason, that's going to be the base account. So base, and the base, I'll also let the base pay. That's who we grinded that for, right? That's what we added here as well. The source, that's easy. That's the address that we want to send from. The destination, that's the address that we want to send to. Maybe we just send it to the base, to us, just to prove that we can do that. Oh, good point. Actually, the base doesn't actually have, I will need to fund this one just so I can pay transaction fees, because currently it's got nothing, because it will be my fee payer, the base. I could of course have a different fee payer and just sign with this. That would also work, but now I found that it's fine, right? And then the owner that it needs to know, because we also grinded this with an owner, that is the system program. So that corresponds to who owns this account, like what program is it assigned to, the system program. And then, and that's the most important part for this to work, we need the from seed, which is a string, which is the thing we grinded. Those bytes, and in a string it's that. That's exactly what I need to put here for this to work. That's basically my secret. Great. And now we can send this transaction. PX, TSX, transfer with seed. Do you think it's gonna work? I think it's gonna work. Nope. Hold on. Wrong address. Oh, Andy. I called it NDS, not Andy. There we go. Is it gonna work? There we go. We got a transaction. And if we reload this account, then we will see it's just 0.5 sol remaining on this. Because the transaction that we just sent, that the NDS paid for, and that's just a writable account, right? It's not a signer. I'm not signing with this, but the system program still allows me to move the lamperts off of there. Yeah, that's how that transfer with seed works. If my head would also be transparent, you would see that there is the exact secret that we grinded to make this work. And obviously, the regular use case with the system program with seed stuff is not to have an account as a wallet account that you transfer from. Usually, you would grind it in a way that you can assign it to either to a program that you control and then have a vanity address for that program, or the most common use case for this is if you grind the program ID, and I think then you have to grind it for the BPF loader. Or what I think also works, if you grind it for the token program and then you make it a mint. I'm not actually sure if the initialized mint requires a assigned key pair or if it will also take an address that is already created for it. I would need to check. But anyway, that's how you grind vanity addresses with 6 or 7 starting letters. Yeah. Cool. It was fun playing around with this tool. It didn't get me the efficiency that I was hoping for with my GPUs, but also my GPU is just not strong enough. If you have a proper one, or you have a cluster somewhere that you can access, then you can grind nice addresses. And there's this Vast AI. If we use his referral link, then we can get proper GPUs here. But that is too white for me. I'll leave that for you to try out if you want to, if you really want to grind nice vanity addresses. And me, I'm gonna be happy with the one I grinded today. It's a fun one. Just a quick little video that you know about vanity addresses, that you know about this tool, which I still think is pretty fun. And yeah, grind yourself vanity addresses. It's fun. And you now have the tools how you can do that. Let me know if you want me to dive deeper into this and show you how to use this with tokens or programs. And otherwise, here's some other videos that might or might not be related that you can watch. And then I will see you in the next one. If you enjoy Cavemanloverboy's work, let him know. If you enjoy my videos, give me a like. And subscribe if you haven't done that already. And I'm looking forward to grinding more vanity addresses with you in the next one. Until then, bye bye.